All right, in this video, we're going to take a look at factoring trinomials in the form ax squared plus bx plus c. So in the last video, all the trinomials that we factored, those examples, there were no coefficients in front of the x squared, unless you count one. This time we will put visible coefficients in front of our x squared. So to factor quadratic expressions in the form ax squared plus bx plus c, what we're going to do is we're going to use a transformation technique to get them to be more resembling of what we looked at in the last video. So we're going to get them into that x squared plus bx plus c form by multiplying the values of a and c. So we're going to take this value of a and this value of c and multiply them, and we'll transform it into an expression x squared plus bx plus whatever a times c is. Now, the thing to keep in mind where most students make their mistake with this technique, it does eliminate a lot of the guessing and checking and testing out values for you. However, what you're going to have right here is not going to be the original problem, which means you have to transform the expression back. And I will show you in this video how to do that, but you must remember once you get the factored form for this, that's not what your final answer is going to be. So let's take a look at some example problems to actually see this thing work. So factor 3x squared minus 11x minus 4. All right, first of note, always check to see if there is a greatest common factor before you do anything. In this case, we don't have a greatest common factor, so we can multiply the 3 for a and the negative 4 for c to get negative 12. And so what we're going to do is now we're going to factor, we're going to ignore this 3 in front of the x squared for a moment. Now we're going to factor x squared minus 11x and then minus 12. So now this looks just like some of the ones we did in the last tutorial video, where we want to find two numbers that multiply together to make negative 12 that add to make negative 11, and that's negative 12 plus 1. So negative 12 times 1 is negative 12, and negative 12 plus 1 is negative 11. So this is factored correctly. Now, again, if we multiply this out, what we'll end up with is x squared minus 11x minus 12. However, that's not what the original problem was for us to factor. So this is the point where we have to transform it back using somewhat similar techniques to how we transformed it in the first place. All right, so again, we are not done yet. Do not say this is your answer, because that is not factored. If you multiply it out, it does not give you the original problem. So what we do is the value of a that we had in our problem, which copied up here in the header, is 3. We're going to take each of these numbers, the negative 12 and the 1, and divide them by 3 and simplify. So we get x minus 12 over 3 and then times x plus 1 over 3. Now 12 over 3 simplifies to 4, so we get x minus 4. However, we have here x plus 1/3. And again, if you multiply this out, you do not, even the x times x, you don't get 3x squared, so we're not done yet. Now, the last step is if you still have any fractions, like we have this 1/3 here, we're going to take this denominator and move it in front of the x that's right before it. So we're going to slide any remaining denominators in front of the variable that's right in front of them. So in this case, we're going to take this 3 and slide it in front of this x, and we get 3x plus 1. Now if you multiply this out, x minus 4 times 3x plus 1, and combine your like terms, you will get 3x squared minus 11x minus 4. So again, you can transform it to make it look like the problems in the last video, but you have to remember to transform it back, and this is the process. Just take those numbers, divide them by whatever your value of a was, and then simplify. If you have any remaining fractions, move the denominator in front of the variable right before it. All right, part B, 8x squared plus 2x minus 3. Well, first let's check for a greatest common factor. We don't have any. So we can take 8 times negative 3 to get negative 24. So we can factor x squared, this 2x we carry down, and then minus 24. So we need two numbers that multiply together to make negative 24 that add to 2, and that's 6 and negative 4. However, again, this is not done. We're not done with the problem. We have to take the 6 and the 4. We're going to put an 8 below each one of them. So this 8 that's in front of the x squared, we're going to put below each of those values we got, the 6 and the negative 4. Now let's simplify what we can. 6/8 reduces to 3/4. 4/8 reduces to 1/2. You must simplify your fractions also, by the way. They must be simplified. So we still have fractions, which means we're going to move the 4 in front of the x in the first parentheses, and we're going to move the 2 in front of the x in the second parentheses, giving us 4x plus 3 times 2x minus 1. And if you multiply this out, you will get 8x squared plus 2x minus 3. Part C, 16x squared plus 46x plus 15. So this one, again, there's no greatest common factor to factor out. So if we take 16 times 15, we get 240. So we're going to now factor x squared plus 46x plus 240. So it might take us a little bit, but we're looking for two numbers that multiply together to make 240 that add up to 46. And in this case, the numbers are 40 and 6. 40 times 6 is 240. 40 plus 6 is 46. So taking the 40 and the 6, we had our original value of a is 16. We're going to put a 16 below the 40 and put a 16 below the 6 and reduce them. So 40/16 reduces to 5/2. 6/16 reduces to 3/8. So we have x plus 5/2 times x plus 3/8. Now we still have fractions, so we're going to take the denominators and move them in front of the x's in the parentheses. So take this 2 and slide it in front of this x, we get 2x plus 5. Take this 8, slide it in front of this x, we get 8x plus 3. And 16x squared plus 46x plus 15 factors as 2x plus 5 times 8x plus 3. All right, part D, we have 7x squared minus 55x plus 42. No greatest common factors to factor out. If we did have a greatest common factor, we would factor that out and then factor what's left over in parentheses. So here we're going to take 7 times 42 to get 294. So we're going to factor x squared minus 55x plus 294. So two numbers that multiply together to make 294, that subtract to make 55, are negative 49 and negative 6. Or they add to make negative 55, rather. Multiplying negative 49 times negative 6, you get 294. Negative 49 plus negative 6 gives you negative 55. So, all right, we're going to transform it back by taking the 49 and the 6 and dividing each of those by 7. So 49/7 reduces to 7. 6/7 can't be reduced, so we have still have a fraction here. So we're going to slide this denominator of 7 in front of our x right before it, and we get, as our final answer, x minus 7 times 7x minus 6. And in the next tutorial video, we're going to look at how to use technology to help us factor both the trinomials like in the last video and this video as well. So that about does it for this video, though. Thanks for watching. I'll see you next time.